Hi, Tapas.
Yeah, hi. Hi.
So, uh, guys, let's begin with the basics. Okay, let me try to share my screen. So, is my screen visible?
Yes, Hitesh.
Okay. So what I'll do, I'll try to explain things here. Tapas, maybe you have joined twice from different devices or something. Okay. Yeah, it's good now. So what we can do is, I will probably not be able to see the chat. Okay. So, if you have any doubts or you want to ask anything, then you can unmute yourself and ask. Right? Okay. Uh, so to begin with, the process of learning deep learning as such, uh, the major roadblock that I found in my own career was not being able to understand the research papers or not being able to understand the textbooks that I read around for deep learning. Right. So the reason why I'm saying this is I figured out whatever one person who has gone through a process of deep learning teaches you would only teach 5% of the entire thing or maximum of 10%. Right? There is always a whole lot of it which is there out for research, and every day it is increasing. The sample space is increasing. Right? So, what we can do in order to keep ourselves on the toes or be on top of everything uh, is to build a methodology to understand how do we understand those things. Okay, and for that, I think the basics of the way a deep learning algorithm or a methodology is built needs to be understood. Correct. So that being said, uh, we so in general, why do we usually need machine learning, or why do we need to have things like deep learning is needed to be understood, right? So when we put it into a very simple format, okay, we usually try to solve things because we maybe want it to happen more faster, or maybe want it to happen in a more better way. When we say better, you always can't quantify it other if you don't use some technique to optimize it, right? uh, let's say if you are making a curry or you are making some uh, dish for yourself and you say you want to make it better, you would want to, how would you make it better is by optimizing the way you cook or having the right ingredients, right? So having things right. So there are some other examples also, like uh, what is the fastest time to travel between 2 points, okay, which is the best stock to invest to maximize your profit, right? Who is the best customer on which you should invest, who would be retained? Now all of these need optimization techniques. Okay. Now when I say optimization techniques, uh, as we were trying to quantify something as a good dish or a good or a first time to travel or best stock or best customer, these qualitative words can be quantified in terms of variables, right? Now, what do I mean by that? If I have to quantify that Sachin is a great batsman or good batsman or a best batsman, I have to quantify that statement using variables. How do I quantify it? And what are the variables? Let's say, for example, uh, his running speed between the wickets, right? Let's say his number of centuries, right? Let's say number of wickets he has taken, number of match winning innings he has played. Okay, let's say these are variables which would define the best or those qualitative terms which would mean an optimized approach. Okay, let's say these variables are x1, x2, x3, x4, etc., etc., right? And we want something to be exceptional, to be very good. Okay, let's say x1, x2, x3, x4 are the variables where which would give you, and your desired result is something. So desired results is something good, right? Now, when you say good, it can be this also needs to be quantified, that what is your end result, like what is the average score. If you say a batsman is good if his average score every match is higher, then probably average score is your measure, or number of matches in which he has won. This can also be a measure, right? You see where I'm going? What I'm trying to say is, now you have built it into this way. You have some variables and you will have some score. Correct? Now, this is something on which everything depends. Your whole experiment or your whole analysis or the way you say best or good depends on this. Okay, these variables would lead to this, right? So we call it dependent variable. Okay, and these are independent variables which lead to this dependent variable in a way. Okay, now, but what we have not done is to analyze different players. Now, this is for one player. Let's say there would be other players and so on. Correct. Now, the variable names cannot change. X1 will remain X1, X2 will remain X2. What would change is the weight of it, right? Running between the wickets, someone is fast, someone is slow, etc., right? So we'll have a weight of it. So basically, I'm trying to give a unique weight to everyone. Equal to score 2 dot 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 equal to score n, right? Now, if we have this, what are we trying to solve is for what values of x or what optimized values of a will we have the scores or the desired score, right? So how do we break this problem is a1, a2, a3, a4, dot dot dot, an1, an2, an4. This when multiplied by x1, x2, x3, x4 would give me a result of correct. So what I'm saying is this is our problem statement that we found out. But when we do it in a computer, it converts into something like this. Okay. So why does it look very different? Is because we are using something called as this is called as a matrix. This is called as a vector. This is also called as a vector, right? In most of the books or in most of the uh, things that you read, research papers or anything, you would find matrices as a very important thing and vectors. Correct? Now, though we would figure out the unknown variables using matrix and vectors, but then we also need another part of it or another thing that what change do we do in order to bring out the optimized results in whatever we have found out. Okay? What is the change? We call it delta of any function, right? Delta means change. Or we also call it differentiation of that function, right? Which both of them we call it as delta or change. Uh, Sorry guys, I guess I lost. I got disconnected. So where was I? Can somebody?
The differentiation part, dou by dou x of f of x.
Okay, yeah. So um, what I was trying to say is we build a logic of how do we solve it, and that logic needs to be transformed into a computer system, and that gets transformed using linear algebra, which is combination of matrix and vectors. And those matrix and vectors then go through a change, or they traverse through the path, a certain path, which we'll discuss in some time, using calculus, or uh, basically we also call it differential calculus. Okay. Uh, so yes. So first, we will try to understand or build our logic around how do vectors work. Once we build an intuition around vectors, then we can jump on matrices as to what do matrices really impact, and how do they change the way vectors are being looked upon. And then we'll figure out some of the functionalities of matrices, right? Now that being said, uh, linear algebra is in itself quite vast. We are not going to understand the basics of linear algebra, and we are not going to solve problems around it. We are trying to understand the concepts in an intuitive way, so that when we do the real derivations and when we do the real understanding of deep learning algorithms, you don't get stuck in a concept. Okay, or you identify a way to figure out the logic what is being done upon, right? So today we'll focus on linear algebra. Tomorrow we'll focus on uh, calculus a bit. Okay. uh, our time is quite limited, probably 1.5 hour or 2 hours or so. uh, I'll try to convey the topics as much as possible. If I feel that some topics are being left out, I'll make videos out of it and send it to you. Those would be more conceptual videos. Okay. Now, what you will do is I'll also send you a list of things to do, or things to read, or maybe sort of assignment which you will go through, right? And wherever you find any problem that you don't understand, you would personally ping me, or you would ping in the group, so that somebody else who knows it, or I will do my research if I don't know, or if I know, I'll explain you then and there. Okay. So I want these classes to be a two-way learning process where we both give similar efforts to learn and build upon the basic concepts. Okay. Now, coming back uh, to a very simple problem, just to give an similar analogy as we did in the last class. Somebody is asking something.
I think Vipul has switched on his mic.
Okay. If you're not asking, guys, you can probably switch off. Okay. So let's take an example that suppose there are two apples and three bananas, which cost you 8 rupees, and 10 apples and one
Hitesh,
banana, which cost.
Hitesh,
Sorry.
are you sharing your screen?
Yeah, yeah, yeah.
Yeah, I cannot see.
It's not visible.
Uh, Thanks, guys,
Thank you.
telling me that. Okay. So I was telling you about an example that some item A, some item B, when uh, in a particular quantity, if bought, would cost you suppose 8 rupees, and maybe apples and bananas cost you 13 rupees if bought in different quantities. Okay. We usually solve it as we just explained. 1. Okay, now this is a matrix, as I said. This is a vector. This is a vector. Okay, we'll come back to this problem again. First, we will understand what are vectors, how do they work, and how do you build an intuition around vectors, right? And then we'll work on matrices a bit, okay? And we'll understand how do matrices impact the vectors, and what are the other forms of matrices that we use. Okay, so I'll try to build the basic intuition at the start. Once you catch those intuitions, you eventually in the class we can focus more on the uh, properties or mathematical part of it, where I abstract the uh, basic intuition part, right? Because if I keep digging down every concept, then the time would never suffice, right? That being said, wherever you have a problem, you can reach out to me. And also, first, I would want you to experiment with your doubt, right? Now, let's look at a more deep learning kind of a concept to understand how do uh, the vectors actually work, and how does the calculus really work. Okay. Now that being said, vectors, every science field has their own expression for vectors. Physics has a way where it says the dimension has a value spread around it. Okay, when I say value spread around it, how does one particular object have a value spread in a dimensional space or in a dimensional space, right? Where okay, that is how a vector in physics is defined. Probably a xy curve, and there is this vector, let's say r. It has a direction and it has a magnitude, right? In computer science, we usually talk about vectors as a list, a set of numbers, right? We will try to see how do we marry these two and understand these concepts using concepts of physics, because it is more geometrical and you can have a view about it. Okay, right. Now the example that I'm talking about, uh, yes, I gave you an article to read about, was about normal curve. Okay. Uh, Let me ask you first, what do you think about normal curve, and how important is this normal curve in our day-to-day lives? Can somebody answer that?
Predominantly, almost all kind of a distribution, or as a the Gaussian normal distribution represents a day-to-day data set, like height of person, like a population or a group of people. So using that, we can get to know the statistical properties, and it gives us the density of the whole population, like what is the mean height of that particular population, or the group of people who are being represented by that particular distribution. So various statistical properties can be derived from that particular the distribution, the way the distribution looks, and hence how much it is widely spread can be I mean can be intuitively reached out, and the standard deviation can be hence derived, and various other factors can
Okay.
the insightful of the data can be taken out from that particular normal distribution. That is the
Makes sense.
overall.
Makes sense. So when you say that, what is that curve? What is inside that curve? What does it mean? What is the meaning of the area of the curve? We understand that it represents population, it represents this and that, but what is it? Is count? I don't know. What is it? It is a frequency measure. It's a group of
It,
histograms. What is it?
it is an histogram where you will have a kernel density estimation is done on top of those edges of the histogram, and hence the probability density function is being plotted. That is nothing but the normal curve, according to the mathematics, if I'm not wrong.
Probability density function, by which means that the curve or the area under
The
it is
curve
a
which is
probability.
traced out is based upon the histogram's edges.
Okay. Okay.
So you are
Uh,
grouping the data from 0 to 10, 10 to 20, 20 to 30, and so on, depending on the bin size that we allocate. And on top of that, we just join the points of those histograms, and we find out a smooth curve, which is the normal curve.
okay. Yeah. So what Abhishek is Abhishek, right? Abhishek, what Abhishek is trying to say is you have a histogram, right? There are many histograms like this where these gaps are also having one value of histograms, and you connect them all, then it forms a density graph, or it becomes continuous. Okay, this is something which he means to say by normal curve, and it is quite widely used. The whole concept of statistics probably is based on something called as normal curve, or we also call it Gaussian distribution. Okay, now how do we differentiate different normal curves? We have a mean and we have a standard deviation. Okay, anybody who could not understand what I'm saying, right? I presume that's an yes. Okay, so there is a mean and there is a standard deviation. Okay, so for different examples, uh, Abhishek just said about weights of people. Suppose you are calculating the weights of people in India, you would find that it becomes a unimodal graph where a point of average gets spiked up. Okay, so this point we usually term it as mean, or we call it as expected value, which means if you select the population of India, probably a person would weigh this much. correct? And then there is standard deviations. It would deviate in a particular range, which we call it standard deviation, right? Now, what could happen? Different countries might have different values, right? When I say that, I mean mu's might vary, sigma might vary, which would lead to different normal curves being formed. Okay, if different normal curves are formed, now this area gets overachieved and this area is undermined. Right? Let's say average age of so the average weight of India is the ideal one or something that we want to reach. Now every country will have its own normal curve, right, which might not be perfect because we have considered our target variable as India, which is perfect. When I say target variable, I mean dependent variable. Okay. Now, as Abhishek mentioned, there is a function, a probability density function, which would give you this curve. Right? Don't worry about it. It looks complex, but what I mean to say is in this equation, if you put sigma value and mu value, right, you keep forming these curves. So only two variables are variables. I mean, we have only two variables. Rest are quite constant in nature, and x is anyways the concept that we discussed about each batsman, right? These are values of each occurring values. Okay, so we have two variables which would impact the values of x using this function to form a curve like this. Okay, I find this explanation very interesting. Saying, let's say, let's try to plot mu and sigma, right? Where because we have only two variables, we are trying to plot these two variables. This is mu, this is sigma over our coordinate axis. And this is the point which we are saying is the most optimal point or the desired point, which is India. Okay. Let's say a curve is formed where the mu shifts to the right. Let's say it's here. Okay. Now, what has happened if it moves to here? Okay. So this is deviated from the good result or the best result that is desired, right? So let us call it the goodness of fit. We want to fit everything into this good value, and whichever deviates is not good for us. Okay, now the mean might decrease also. Let's say it forms here, correct? Now this is equally bad as this. Let's say these distances are same, right? How are we saying whether it will be equally bad or not? The area which is undermined is similar in these two cases. Now the area could be similar for a certain sigma value also. Like if mean decreases, these values get more uh, undermined, while if sigma increases or decreases, the value on the peak changes. Right, so the area could still be uh, the area of not having a goodness of fit could still be same if the sigma deviates. Right? Similarly, we could have a value for a negative or a decrease in sigma. Right? Let's say this is a circle which forms a similar level of bad results. So we'll have similar many circles. Correct. Each of these circles would have a value of mu and a value of sigma, where the area which is not desirable gets populated. And what we are trying to achieve here is we are trying to achieve a goodness of fit. Okay. So let's say we are somewhere in this. Let's say we are somewhere here. Okay, and our aim is to reach here. Now, how do we reach? Okay, probably we'll traverse from here to here. Correct. Now, this traversal thing that I'm showing here is a vector, right? If I keep traversing in this way, I don't know where will I reach. Okay. So what am I missing? Why am I not reaching here? Is the direction or the amount of change that we need to do in a particular direction. So probably we need to move in a direction like this, right? Now, how do we come to know about the amount of change or the amount of shift in terms of direction? Okay, this deviation from here to here is calculus. Okay, so what I tried to do in this example is basically shifting the logic from the generic concept of matrices and calculus into a more focused deep learning concept of vectors and calculus. Okay. Anybody has any doubts till now?
Sir, the mu and sigma, the x-axis and the y-axis. Is there a
Yeah.
specific name for this graph, like the circle structure that you have drawn?
Uh,
I mean, mu as 0 and sigma as a value of 1 is nothing but a standard normalization. So that is what here
yeah.
are you trying to achieve, or how did you come across this graph? Uh, because it's very new. I haven't seen in any video. So
Okay. So the thing is, I read it in one of the books. Okay.
Okay.
Now, what does this mean? Is don't think about standard normal thing or Gaussian explanation or anything. Okay. Think of think of it as a curve that is desirable. Now, that's why I gave an example of a curve that is formed by the weights of people of India.
Okay.
Right. Now, I think that the weights of people of India are, I mean, is the best. You should ideally have a weight as the weight of people existing in India. Now, what I'll do, I'll go over all over the countries and I'll start measuring the weights of other people, right? Now, the normal curve or the curve that is formed out of other people's weight or other countries' people's weight won't be the exact curve as the people of India's weight, right? It
Yes.
would deviate a bit, right? Now, that center point, which we consider as the basis of calculation in coordinate geometry, which we call it
Okay.
as
So you
zero,
are
zero.
using it as a golden sample, and with the reference to
Exactly.
that.
Exactly.
Okay.
With reference to that, how much are you deviating?
Okay.
Okay. So one country might have a higher mu, one country might have a smaller mean, one country might have a higher deviation, right? But all of these are, deviating from the goodness of fit. The
Okay.
goodness of fit I am trying to say is India. Okay, now those deviations would cause a certain error, and I'm the circle that you are seeing. One circle means in each of the points of those circles, the goodness of fit is being deviated equally, or the
Okay.
area which is not under the normal curve of India is deviated.
Hmm.
Okay, now this is like any real-time example in any example that you take, that you have variables and you find out graphs uh, which are uh, showing the mistakes or the problems in the movement caused by the movement, right?
Hmm.
And your whole exercise of deep learning or machine learning or optimization technique or anything is to reach to that optimal point.
Hmm.
Okay? And how do you do it? You do it using vectors where you have those values in your computer system, and you use a bit of concept of calculus to direct those vectors in the right direction.
Okay.
Okay?
So this is the intuition behind optimization. Optimization, is it?
Optimization techniques.
Okay.
Yes.
So this is the thing.
Now,
Like you are trying to achieve the golden samples nearest to possible value by adjusting the vector values.
yes, yes.
Okay. Got it.
Now,
Got
when
it.
I say that, uh, those who know machine learning or already are data scientists, they would be very familiar with this term called as gradient descent.
Yes.
Okay? Now, that gradient descent curve is formed out of variables, right? Now, the deviations in those variables are the imperfections or the errors. Or so we have two or three kinds of errors. Some can be reduced and some can't be reduced, whatever it is. But those errors form those curves. Now, your agenda is to reach from any point of those curves to an optimal point. Those the way you reach to that optimal point is achieved through matrices and calculus is what I'm trying to say.
Okay. Sure. Understood.
Okay.
Yeah.
Yeah. Any more doubts? This I'm giving this a lot of time. We will probably not give a lot of time into all of the concepts. So, as it is a building block, please ask your doubts. It might be as you might think that it is a very dumb question to ask, but it is actually not. Please ask. Okay, then I'll probably move into the concept of vectors. Uh, Now, why are we studying the concepts of vectors? Uh, for those guys who already know the concepts of machine learning and a bit concepts of deep learning or natural language processing already, you would know that storing a image into your computer system would form something called as a matrix or a set of vectors, right? Uh, Having a set of natural language or English sentences into your computer system, you would need something called as vectors, or you form a vector space out of it, correct? Any of these concepts, you would always need the basics of vectors and the way you can manipulate them, right? Let's say a image is tilted, okay? You would want to have it in a correct format or in a more uh, in a way, in a more readable format. Okay. Now suppose you are doing a OCR or you are dealing with an NLP problem on a document, and that document is tilted, right? You can't read an alphabet A as it is tilted to an angle of 20 degrees. Now you have to normalize it in a particular way, right? Now everything you would work on them using the concepts of vectors. Okay. And for those who don't know about machine learning or these concepts, basically what we're trying to say is anything that you deal with in deep learning or machine learning, any object, maybe a voice recognition, an image recognition, understanding of English, anything, all of these are first converted into digits or numerical format. They are stored into your computers. They are stored in formats which are vectors or a combination of many vectors causing matrices, and we do manipulation over it so that it is humanly understood or in a format where human can understand, right? And then we work upon it to bring upon our desired results. As we said in our previous example, we try to reach a goodness of fit. Okay. So that is how vectors become very, very important for you to understand. Okay. As we said, we'll combine the concepts of physics and the concepts of computer science. Right? Vectors in physics are probably something like this, which move around a space, and something in computer science is a list. We are trying to say is both are similar. Okay. Now, a house can be, doesn't look like a house. A house can be a vector saying I have 2 bedrooms, I have 1000 square feet, my cost is 1.5 lakhs. Okay. Conceptualizing an entity into computer system is this format of vector representation. Okay. But we have figured out a way where these vectors can have the same manipulation methods as the vectors of physics. Okay, let's see how. The most important concepts of vector are addition and probably a scalar multiplication. Right? Who doesn't know what is scalar? I mean, it's okay to not know, but I just wanted to know so that I can deep dive equally. Right. So if I have a vector which is say R, okay, and I have a vector which is S, right? Now the resultant vector is something which is traversing in this direction, right? Let's say I bring a synonymous version here and call it S, or a synonymous version here and call it R. You can go from here to here causing this, you can go from here to here causing this, right? So this we call it as R plus S. Okay. Similarly, if you have two vectors which is 215 and some other values x1, x2 and x3, if you add them, you would probably reach to a synergic value or a synonymous value as this vector. Hello, has Asif joined? Asif, you're there? Okay, I'll continue. Right. Now you would have found it difficult to understand how does this mean this vector or this mean this vector. Okay, let's say this is our coordinate system. You remember those mathematics books? We had small cubes representing coordinate system, right? So suppose these are those mathematical books, and this is one unit. Okay, this is 1 0, suppose, and this is 0 1, right? Because we are looking at a two-dimensional space. What I showed you here is a three-dimensional space. Okay, let's understand the concepts in a two-dimensional space so that um, you can then have an intuition around n-dimensional space. Now that being said, the properties do not change, okay, in whatever dimension of space you have. And when I say dimension, if x and y are two variables, sorry, x1 and x2 are two variables, as we saw mu and sigma in the previous example, we could have a third dimension also called as x3. Okay, we could have a fourth dimension also, which comes out from here towards you. Okay, thing that Einstein said as x, y, z, and there is another dimension called as time. He meant something as this vector representation. Sorry, as this dimensional representation. There is x, y, and z, and there is a time which is going moving towards you. Okay. Now we'll not complicate things with n-dimensional space. We'll understand in a two-dimensional space. Okay. Let's say this is a two-dimensional space of x, y coordinates, and this is unit vector. Right. Let's say I have an R and I have an S. Okay. Uh, let's say this is 3 and 2, and this is -1 and 2. minus 1, and this is, suppose, just 2, right? Now the resultant vector is something here, which is equal to 2, 4, right? If you add directly, it will be 2 and 4. 1, 2, see it reaches here. Okay. Are you getting me when what I'm trying to say?
Yes, it is.
So this vector has a number called as 3 and 2 when we have a reference to say that this is of so and so length, and according to this length, this has a particular value which is 3 and 2. Similarly, this vector would have minus 1 and 2, and when we add both of them, it would become another vector, which would probably be a synergy. Okay, you understand synergy, right? Which is collaborative efforts of two forces acting together, right? When we say vectors in physics, those are forces. They have a direction and they have a amount or a magnitude, right? Now that synergical thing that happens, we can have a addition value on it to show how does that synergy happen. That is this way. Okay, now this is the basics of addition of a vector. We also have a scalar multiplication. Let's say this is r and we multiply it 3 times, so it will become 3 times of the original vector space. Okay, so basically it was 3 2, it would become 9 6. Hey, what is happening? Why are people joining again and again? uh, are you guys missing something? Whoever joined late, can you just tell whether you have missed something, or are we facing a problem? I left again. Okay. Yes. So there is one property which we call as associative property, right? Which means r vector plus s vector is equal to s vector plus r vector. I explained this property probably here. Can somebody tell me how does it work? Let's say this is r. Let's say this is s, and this is r plus s. Does this property exist for these vectors? Okay, so what I mean to say, r plus s is equal to s plus r. Right? This property is called associative property. Right? Now there are certain things with vectors that you can do, like you can find out the length of vector, you can find out the dot product of a vector. Okay. Now, one of the caveats that I have seen is people use PCA for dimensionality reduction, but uh, there is a bit of gap in terms of understanding how does this decomposition really work, or how does this projection really work. Okay, and what does PCA really mean? Correct? Can somebody tell me what does a vector projection mean?
Let us say R plus S is the end product like Z or something. Okay, so for for that vector, if you are going to take the projection, it is getting decomposed into X component and a Y component. So it becomes Z cos theta and Z sin theta. So Z cos theta is with respect to the x-axis, that is the r vector, and Z sin theta is with respect to the s vector, s-axis.
Correct. Correct. So that vector decomposition again happens in the similar format as you said in terms of phys. So your concept that you explained was more in terms of the physics vector decomposition, right?
Yes.
That similar concept is done in uh, our representation of vector in system, which is using a set of array or a list, right? So let us look at concepts which we call as length and finding out the length and finding out the products. Okay. Uh, as we were looking at this, there is I, there is J, which let's say has unit length, and we have something called as R, which has a vector value of 3 and 2. Okay. So how do you calculate the magnitude, or what is the value of this vector?
Three times of I plus two times of j.
Correct. Is 3I plus 2J, but if you have to find the length, you would use the
Square
Pythagoras
root.
theorem of 3 square plus 2 square. As simple as it. We also call it the magnitude of R is represented in this way. Okay. Uh, Now we have something called as product. Okay, we call it inner product or dot product. Okay, how do we say what is it? Let's say there is. Uh, Wait. Let me first explain the old concept of cosine rule. If we have a triangle which is having sides A, B, and C, okay, we could say the side which is opposite to the angle, we know C square is equal to A square plus B square plus minus 2A into B into cos of theta. something called as cosine rule, right? Now we will use a similar concept to find out the dot product of our vectors, right? Let's say this was a vector A and this was a vector B, and if you move from this, so the resultant would be probably something, a movement from this direction to this direction, and we would calculate the value of C in this format. Okay, which is also, if we say that this is R and this is S, this is probably minus of S and then addition of R, correct? Minus of S and then addition of R, right? So R minus S whole square, correct? This is my equation 1. Okay, I can also write it as R minus S into S, which is equal to R into R plus S into S. Write it as this way. Square plus S square minus 2S into R. So we call this part as the dot product. Okay. This is probably something synonymous to this part, where we'll say 2R is equal to S. Cancel this. Sorry, this is a positive. Less R into S, dot product of R and S equal to magnitude of R into magnitude of S into cos theta. Okay, this is a more mathematical derivation of it. If I have to really tell you what does it mean, there is an R, there is an S. Okay, let's say this is theta. This is 90 degree. Okay, the synergy would be something where we would want the decomposition of this vector on this vector, right? Which is finding out this value, say A, B. Cos theta is equal to AB by S. AB is equal to S into cos theta, right? That is what we are doing here, right? Probably I'm trying to find a decomposed mod value of this vector on this vector to say what would be the synergy value, right? So which makes it R into a decomposed S vector. correct? So this value, this method is called decomposition over another vector. Okay. This might seem very trivial, where you would feel that it is not really important, but uh, as we go ahead and learn different concepts or try to implement various algorithms, you would many times come across these decomposition methods. Okay. We have algorithms like SVD, uh, or we also use it in PCA. Okay. We also use this decomposition methods in NLP, where we want to see how does one word vector, uh, give an example for a better understanding. So in terms of NLP, what we do is we say this is a vector pointing to one word, this is a vector pointing to another word. Okay. We try to find the similarity between these two words using something called as cosine similarity, right? You also do the cosine similarity while identifying the images, okay, or any other set of numbers. You try to find the similarity or the distance between them using cosine similarity. Now that is based on this concept of dot products or decomposition of vectors, right? Small things, but then they eventually grow up. Okay. Any doubts? Cool. Yeah, somebody's asking something. Changing basis. Uh, this is one another important concept, and probably a concept which I have used a lot. Uh, so as I was saying, if there is a scanned document that you want to read and understand, so suppose there is a scanned image, okay, that you want to do an OCR, and then you want to figure out what is written on it, etc. And the scanned image is probably tilted, right? And you want to bring it to the same axis depending upon your basis, which is your paper. You want to bring it parallel to this, okay? Or you have a, so this is a human being in an image. Unfortunately, you have a image which is like this. You would want to bring it to a system which would give a direction parallel to this basis. Okay? Basically, what you'll do, you will try to figure out how to convert vectors or convert it into a different changed base. Okay? Probably a concept that you have read in your mathematics in class 10 or 12, but you have not figured out that it would be used in such real-time applications. Okay. Uh, let's see with an example. Let's check our previous exam with our previous example where we did I and j, which is, let's say, two unit vectors, e1, e2 is 1 0. and 0, 1. Okay, and then we have two vectors, which is r. No, let it be just r, right? Let's say r is 3 and 4, which means 3 times of e1 plus 4 times of e2. Correct? I want to convert it into another changed base. Let's say this is minus 2 and 4, this is 2 and 1. Increased it a bit, but just for the sake of understanding, think that it is 2 and 1. Okay. Now, if the basis is changed, correct? How do I represent this vector in terms of these vectors? Okay, basically this is RE. How do I convert it into RB? Can somebody think of a logic? How do we do it? Just in terms of representation.
It is an angular transformation, so we can multiply with some scalar or vector value which eventually gives us the resultant. That is uh, b1 and b2's resultant can be taken and some transformation can be done.
B1 and B2's resultants can be taken and transformation can be done. We can do any answers, any more answers. Who was answering? Abhishek was, right?
Yes. Yes.
Uh, who else? Can you figure out what to do? How do I transform this? And this is probably nothing new. The same concepts of cosine decomposition, right? Over a vector. Right? I wrote this out because this is what you will Google. This is what you will do to figure out how do we change the basis for the vectors, okay, and represent the same r vector in terms of b. This is your assignment.
I 3 and 4 can be kept as the end result.
Abhishek, do it and share it. Okay,
Oh,
do it
okay.
on a pen and paper. Take a photo of it and share it in the.
Group.
I'll send a mail ID where you can send
Okay.
it to.
Okay.
Okay? So all of you can also do this. Okay, you can find out how do vector change their basis and how do we do it. So this is an important concept, but quite easy if you think logically. Okay. Ah, So, guys, I want to start metrics, but then this would again take hour or so. Ah, hmm. So let's do this. Uh, you find the answer to this question, okay, before tomorrow's class, right? Tomorrow's class will take the concept of vectors or the logic that you develop in this assignment into matrix manipulations, and then the matrix manipulations into the basics of calculus. We'll do a part of calculus, right? Then in the next class, we'll do second part of calculus and the implementation of vectors and matrix multiplication on Python. Make
Okay.
sense?
Okay.
Right. So probably I have discussed concepts which are quite complex. You would want to go back and Google out things. The recording, I'll share it. If you don't understand anything, reach out. Okay. Don't get puzzled and keep looking forever. Okay. Put in good effort of 2 hours, 2 to 3 hours, or maybe 1 and 2 hours. If you don't find, reach out. Okay. So that's it. I am halting the class here. I hope you would complete the assignment before tomorrow's class and then we'll discuss ahead. Okay, this seems boring, but these are the building blocks without which, if I explain the details of deep learning algorithms, you won't understand. Okay. Thank you, guys. That's it. Any questions, please?
That's
Who did not understand anything?
right. It was a good session, Hitesh. No problem.
Okay. Okay. किसका पूरा बाउंसर गया?
I think people are not interactive.
Yeah, that's okay. They will automatically become when we look at the assignment. Right? Okay. Okay, guys. That's it.
Thank
Thank
you.
you all.